a pretty amazing engineer, actually.
Yeah,
The
no,
stuff that he
absolutely.
does.
He's a little crazy, but he's interesting. I think we're all a little crazy, but I like what he's doing with that.
He's, I think he's not, he doesn't have the social norms that we expect of people.
Yeah, yeah.
And so that's why he kind of rubs people the wrong way all the time.
Well, he's
He's very demanding.
yeah, probably a little Aspergery or something, one of those
Yeah,
spectrum things.
maybe. Yeah.
Um, uh, but he is getting cool things done, not the least of which, as you say, landing the retro rocket after the
Hey,
fact
Bill.
is,
Oh,
oh,
Hey,
hi. Yeah,
gentlemen, this is my friend Bill. He's in Illinois.
okay.
Minnesota.
Oh, sorry. You're across the other side. Okay, sorry.
Not that I'm proud of it right now.
Well, yeah, we won't go there.
Right.
We were just talking about the SpaceX launch, and we're all kind of
Sure.
excited about those little engineering feats they were doing yesterday, and even today's docking was kind of impressive too. Yeah.
yeah, and it's so funny. I'm just watching the feed now, and they're setting up like 20 cameras in the space station.
Well, they're making history.
Like,
Yeah.
everything's got to be recorded now. Like,
Yeah.
it's just wild.
Yeah.
You've got PR, quality assurance, plus you happen to be making history. I mean, imagine if they had cameras when they were building the ancient pyramids in Egypt, it'd be a different game today. A lot less people would believe in UFOs.
Well, we also wouldn't think that the world was flat. Yeah, it was interesting. I don't remember it was on the Saturn missions. I don't remember the level of detail that we saw yesterday. They were talking about filling the turbo pumps with liquid oxygen to cool them down so that you're not running gas through them, which explains what all that bleed gas out the outside of it is, even though that's not the point where you're fueling it. It's when you're cooling the chambers of everything. So I learned a lot more about it. Perhaps it's because now I have a different insight into how these things work, but still, it's really interesting. So
Yeah,
have you
for
been
sure.
working on some interesting projects while in this sequestered state?
Yeah, actually, I've been doing a bunch of stuff with a simulator. It's kind of cool, actually. So you guys saw my donkey car, right?
Yep.
Which is the autonomous driving car.
Yep.
So we've actually moved that to online.
Okay.
And there's a guy that built a simulator.
Mm-hmm.
And you can actually you can drive your car. You can have a model which is feeding steering and throttle information into the simulator.
Okay.
And it's driving this car around in the simulator. And so we've actually had a couple of races with that setup.
Interesting.
It's kind of interesting, actually. Yeah.
Yeah. That's I'm trying to figure out what question to ask. So how do you get the telemetry of, I mean, you were using vision systems in OpenCV to track. So within the simulation, is the simulation giving you frames of data so that you can figure out? Okay.
Yeah, so what's it doing? And it's it's done over the net as well. So when we do a race, he's running the server on a laptop in San Diego, actually. And then everybody's connecting to him from all over the world.
Okay.
So we actually we have a guy that is running he has a host, I think, in San Antonio. So we SSH into there and run our model from there just to decrease the
long range load and
the latency.
Yeah.
But there's some guys that are connecting from Japan and they're handling the latency. They're kind of predicting. They're doing their frame prediction a bit differently. Okay. But yeah, so what it does is the simulator is sending an image every 1/20th of a second. It's 20 frames per second, I think is what he's sending at.
Okay.
And then we take that image, we feed it through our model, we get the steering and throttle output, and we send it back to the simulator.
Right.
The simulator moves the car. And
the virtual car?
Back, the virtual car. And then feeds us back the image again. So it's
Do
And
you
it's
get to
pretty cool.
design your own virtual car or modify that, or you only get control of the feed mechanism back? So you're only sitting at that one point where you're looking out of the car and controlling what that virtual car is doing, or do you get to tweak both sides of that?
Yeah, so there's different aspects to that question, actually. So there's the car physics, which right now is fixed. The actual car kind of model and look, he basically has three different choices, and you can choose between three.
Okay.
So
that's just an aesthetic shell or something.
Exactly.
Yeah.
And I
Okay.
think, I mean, he could probably open it up. Like I don't know much about. It's written in Unity. I'm not a game programmer or anything like that. But
No, I've
I
heard
mean,
of
it's just
that.
it's like 3D.
Yeah.
You know, it's basically 3D graphics, 3D GUI, and creating an object
I think it's
with
an
a
avatar
mesh.
type thing. Yeah.
Yeah, like just exactly. And then somehow using that as a model in the simulator, and it can just.
So on the physics side of it, then, is it
Mhm.
not useful to be able to, in terms of what you were doing with your robot donkey or whatever you call it, you have some interest in being able to model the speed of your motors or how fast you can actually turn them or how fast they react. Can you control those levels of parameter on his server model? Yeah.
Yeah, he's actually built the default model he has is built on a donkey car.
Okay, cool.
And he has I mean the steering and all that is actually emulating or simulating a donkey car.
Wow.
So yeah.
That's very cool.
So it's been a lot of fun, actually. So we've been able to do our exact same workflow.
Yep.
Like
but
what
virtually.
I do. But yeah, exactly, virtually. Like we train, I can run the simulator locally on my computer.
Okay.
And then I run my model, and it's driving the car around the track.
Yep.
And then, and then after that, I just collect the data, and then I'm driving manually first, then I collect the data, and then I build a model, and then I test the model on the simulator again. So it's the same workflow, basically, yeah.
Well done. You've virtualized
cool.
No, that's super cool. That's really, I think that's awesome. This is kind of a mind bend, actually. I'm thinking, well, yeah, there's just so many questions that come out of that. I'm going to have to think about this a little bit because that's a really interesting way to play together. Remotely working on the same thing, but you're not actually having to, again, go anywhere. Darcy's arranged a bunch of, one-on-one or little group meetups as well. And we're finding that this, not that we would ever have gone to Zoom pre-corona, but now we're really keen on this style of meetup where the overhead of getting to the meetup is zero. So you can call it in relatively short order for a short window of time and move forward. And we're all sitting in front of the toys that work, as opposed to bringing our wandering pony show. You're bringing your donkey car, and it's like, oh man, this is heavy. I got to load it up, and in the winter, it's. Hey, Greg.
No.
Right.
Hey, Greg.
Yeah. People now.
Yeah, for sure. It's been interesting because I know this. We as a group, they were trying to figure out how do we continue to work on the stuff.
Mm-hmm.
And and the guy did I mean, we knew about the simulator. I've been using it before.
Yeah.
I think one of the cool things would be to try to get it something you trained on the simulator to actually work in the real world. And that's that's kind of the big thing if you could do that.
I guess the trick there is the simulation environment is not your environment. So unless you can photograph your environment and feed that into the simulation, it'll be hard to transition from one to the other.
Well, it's just, I guess what you're saying is you want to build a realistic simulator environment.
Yeah.
And people, he's done that for a couple of actually events already, and we're trying to figure out how he did that.
Okay.
But it's kind of cool, actually. So I'm going to try to, I'm going to try to find out some links here, and you guys can
Okay.
take a look at what it looks like.
Yeah,
I know
yeah.
there's some YouTube stuff too. So yeah,
Nice.
let me look at this.
By the way, Paul, it's good to see you. You haven't been here around for a while, have you?
Yeah, I was just telling Doug, he was asking me what I've been up to. I was just explaining, I've been doing a lot of stuff with this autonomous driving.
Yes,
my
right,
donkey
right.
car. But now we've gone virtual. We're doing it inside a simulator now.
Okay.
So, I mean, the past couple of months, I've just been looking at that and working with the guys building models that work on that simulator.
Okay.
So there's been lots of, yeah, I saw Darcy had put a note a couple of months saying you guys were moving to Zoom, and it's just most of the weekends so far I've been doing this stuff, but
yeah.
I had today off and I said, I got to jump on this other meeting.
Yeah. It's funny how we have all this free time, right? Yeah. The workload expands.
Exactly. We've been doing supplemental meetings to keep up with stuff.
Yeah, yeah, exactly. And there's a lot of different subjects on the go that we hadn't even touched before. So it's kind of it's heavy.
But if anything, Paul, as I said in my email to you a couple of weeks ago, we've found this for our environment, for the kind of things we do, this is a better environment than actually getting together physically.
Yeah. So Greg, just since you're there, do you have your little tractor? The one
that I probably have the photograph. I don't. It's.
Oh.
It's been assembled now. Or sorry, I did the last gluing, which is putting the roof on it, and then but I have to still assemble it. Next week I'll have a series of photographs of it.
Okay.
Because even though in a way it doesn't appear to fit in with what we do, it does very much because so much of it was CNC.
Yeah, it's really interesting.
CNC.
No, no, it's just more. Do you have the picture that you sent me the other day of you clamping up that piece? Because it was just really cool.
Yeah, just let me. Yeah, I'm gonna. Let's see here. I guess I should do this. You have to just bear with me a second. I'm pretty sure I know where it is, but I'm going to do a screen share, guys.
Okay.
Okay, just hold on, guys. What did I do with that? Oh, I know.
I just put a YouTube link in the chat.
I got it. Thank you.
Yeah, you can that was a recording of the race last week.
Is that what you wanted to see, Doug?
Yeah, that's the one I wanted to see.
Nice.
That's
Nice.
really nice.
Isn't that cute?
Awesome.
That is beautiful.
Yeah. I said, I love it. I think it's Poco Bear on steroids. It's got a lot more action going on there. It's got complete hydraulic pistons made of wood.
Holy cow.
Yeah.
That's a good piece of work. I like that.
Well, I knew somebody would say that.
Yeah.
There's no talent involved. This is what you're looking at is basically built by a robot. Is what what we really have done.
Well, don't call yourself that, Greg. You're not a robot.
I have very little talent, so I'm impressed.
That's a work of art.
It is.
That's
So
beautiful.
a piano is a kind of a robot. I guess people that operate pianos, they don't have any skill, eh?
I guess so.
I think you undersell it. It's very cool.
Well,
It's very cool.
You describe it, Doug. Where all these things, arm pieces, which are all glued together. So most of it's 1/8 inch high-grade plywood, which Doug cut in a CNC machine.
But Greg did all of the design work. We've been working this special covert arrangement. So he sends me design files. I burn them on the CNC machine, just carve out the outline. And I'm looking at these wonderful, oddly shaped pieces, wondering, I wonder where that's going and how that goes together. And then the exchange is, well, one or other of us has to get out once in a while. So we pop the trunk of the car and someone grabs something from the trunk of the car or throws something into the trunk of the car, and then we go our merry way. To me, it's a blast because I'm seeing all of these weird little pieces that come together and they form this really cool object.
It's very nice.
Yeah, I'm thinking as a robot platform, like this is one serious Arduino machine. If you put one motor in the bottom of
Never
it.
thought of that. Good point.
How did you design it, Greg?
Oh, I bought the plans.
Okay, that's still cool.
There's an outfit called that's been around for a long time called Toys of Joy, and it's an American outfit, and they sell pretty expensive plans. Also sell like the wheels came from them and the little plugs that form the axles that came with the kit. So what I was basically all I did was take the and what comes is a full drawings that are full size. So what I had to do was take the drawings full size, scan them in, put them into a SketchUp, get it all worked out, get the design recreated in SketchUp. At which point, then I passed it over to Doug, who cut it on his CNC machine, and then
Cool.
basically that what was really neat is the fact, as you see, particularly where this arm here is built up, as you can see, from a number of layers, and of course, particularly down in this part where they're all identical. They truly are identical, which if you cut them by hand, they would not have been by any means. I can see this Toys of Joy thing. I think is, if you look at their catalog, they make gorgeous, the plans are for gorgeous toys, but I think they're really just a way for really good woodworkers to show off, because I'm not sure how practical the toy is. Giving this to a 2-year-old, I think would be the end of it. But but as I say, that all I did was buy the plans and then convert the plans into SketchUp, and then pass it over to Doug. And of course, well, I will show. Doug was commenting here about the. Let's see.
You didn't know how to use SketchUp beforehand, so that's actually also kind of impressive. You're understating that, Greg. So you learned how to do the CNC design. So this
that's true.
It's not insignificant.
Plus, now then this is another aspect. This is clamping. The point is, Doug cuts out the parts, but I have to glue them together. How do you do that? So in this case, the little digger at the front, or the little digger on the back has a bottom piece and a back piece held at an angle at a certain angle. So what I had to do is cut out a piece of wood with that angle right in here. Then put the glue on. Then of course the trouble is, if you build a jig with glue, you don't want the object to get glued into the jig. Well, one way to do it is use metal rather than wood. So what I've got a bar of brass here for historical reason. I have a lot of brass pushed up to hold this piece against this wood with the slant on it. Then I put a bar of another brass rod bar in here to hold that against
so it doesn't shift
against the form. So that is me. That's me having to think how to do this. The other example of that is
right. Oh, Greg, before you go on, if you had a 3018 CNC, you could have made that jig in a few seconds.
Well, right.
You're right.
But I have a bandsaw. It took me even less time.
Actually, another comment on that. Wax paper is good to wrap stuff like that in.
And if you look at this next drawing, you see there's wax paper
there
scattered
you go.
about here. So I certainly have done that.
And elastics, I think, too. Yeah.
The big setup here was what I was gluing in was this little cross piece right here. The thing is, I had initially a woodworking shop, so I have a lot of stuff left over from woodworking, like this huge clamp. See, I had to. So the little machine is actually screwed to the bench, and then the clamp is actually clamped down here, and it's raised slightly, so the tip of this clamp hits where you want it to tighten. Then you get that all set up, and then you slowly tighten the clamp to make it so you get this thing positioned exactly. And it's a bit of a game, because of course you put glue on, but then you clamp it a little bit, and then you can move the part just a little bit to get it exactly positioned. Then you do a final tightening on the clamp. Then you go away for a day.
Wow.
But that's, if anything, I would say where my effort is doing that kind of stuff. The assembly is not trivial. It's not trivial at all. The other thing, coming back to the original drawing, to the original thing here, the other advantage I have is I also have a machine shop. So the thing is, like, how do you drill a hole right down the center of a dowel? Well, with a metal lathe, that's a trivial exercise, because the way all metal lathes work is that's easily done. How that's in the plans, they had a kind of a jig arrangement for doing that when you didn't have a machine shop to fall back on. I feel, if anything, what I find now is that because I've been fiddling around for over the years with both woodworking and metalworking, it's kind of like going bunny hunting. Like, bunny finding, 22 will be enough to take the bunny out. But if I got a really stubborn bunny, I've got a howitzer to go after the thing with. So that's next week I should have the whole thing assembled, and I'll take more pictures, guys. And this is again a good example, coming back to how I definitely would have, if we were still doing physical meetings, I obviously would have brought in, but it's just so much convenient. For now, I can show everybody this. So it's really, really, this is a good way to meet.
Yeah. No, it's very cool.
Yeah, so
it would be nice to touch it, though.
Yeah.
Well,
Someone's got to break it, right?
Yeah, he's not going to let anyone touch it.
Come on, I just got it. Just wiggle it. Just it a little.
the thing is, what I'm going to do is, and this will be totally up to you, Doug. I mean, obviously, I would like to show you, given the role you've played, show you physically this thing. I would like to drop over to your place sometime with it in the trunk, and then we can meet. I'll stand one end of the car, you stand at the other end of the car, and you can look at it that way.
And we'll throw it back and forth.
What's that?
We'll throw it back and forth over the car.
Another comment from my peanut gallery.
Yeah.
Had you had a CNC, making two of them would be the same amount of work as one.
Yes.
Yeah.
No. And of course,
you'd have one for each.
No, and you're absolutely right too, because the thing is, particularly as I say, where a lot of the effort went was in setting up the gluing arrangement. And of course, once you've done one, and doing a second one would be trivial. And
there's an slight inside joke here, because Greg's come online to watch all our CNC stuff, saying he's not buying one. So now I always point out the value proposition.
No.
Pat Beirne buying one, so there you go. It's already on order.
I will get into this discussion with Doug tomorrow on this, but there's.
You could build one from scratch.
Yeah.
No, you
got Doug on your side. Anything
right now. I'll discuss it with Doug tomorrow about getting a CNC machine. Well, that's a whole deal altogether. I don't think they want to get into it in a large bias group like this.
Yeah.
Special deal just for you. I happen to have the 3018 right here on my desk. You can see it in my desk cam. I'm just going to turn on the CNC cam for a sec here. If I can find the button for that. There it is.
I like Darcy as a squirrel. It's quite a good picture.
I freaking hate it.
Oh, you don't like squirrels?
I hate squirrels.
He's such a cute squirrel, though.
Bloody squirrel. Get away from me. This is a no squirrel meeting. I can get rid of that thing.
Well, here's Darcy.
I think the squirrel says nuts to you.
Yeah, it does, too. Ruins everything.
Bloody squirrels. Backward, right? I gotta switch it. Where's the switcheroo button? Right here.
They've been tearing up my garden.
Does that look very CNC now?
It looks very CNC-ish.
Okay.
Oh yeah.
So check this out. So I got it all set up so it can run a job, so you guys can get a sense for, what a $200 machine can do for you. Okay. So I'll share a screen for a sec first to set the job up.
Okay. Go ahead.
So I'll just make a square to keep life simple. Where's the share button? Share screen. Go get this screen, and then I'll load like SketchUp if I got it running here. No. So we'll just go looking for SketchUp in here. A, B, C, D. Here it is. I'm picking SketchUp because it happens to have a fairly quick learning curve. So let's see. You guys can see my screen, right?
Yep.
Okay. So you always got to delete the guy. Well, you can have a guy if you want. I don't.
We don't want a guy.
Yeah, I just find that. Yeah, I don't need a guy in my drawing. So I got myself a pencil there, and I'm drawing, and I want to draw a line this way. So what do you want me to make? Like a 1-inch square, or something crazy
Sure.
like that? Okay. So I haven't clicked down my line yet, but I'm just typing the number 1 and hitting enter, and then for free at no extra charge, that is a exact 1-inch line.
Yeah.
So now the pencil's still there, and I'm going to put it in the vertical axis where it snaps, and I'm going to press the 1 again. Just 1 enter is all that was. And then now I can hover. Now it wants to snap onto that spot, so I can keep going, and that is a 1-inch square. So for extra excitement, I'm going to move it up a bit here, and I maybe you want me to punch a hole in it maybe for fun, and the machine will do that too.
Sure.
How about a hole this size and a hole that size, and maybe a square hole right there. There it is. It's a face. Okay, so that's my part. This is the design. Now you've probably been doing this already, Craig. Am I right?
Yes,
Oh,
yes.
so you're good for this part. Okay, so being SketchUp, you always save, because we all know what happens if you don't save in SketchUp.
Blink.
Yeah, it crashes a lot. But if you save
curse
every
a
2
lot.
minutes, yeah,
Yeah.
cursing. That's one of the things. Now, this extras toolbar is not a SketchUp toolbar. That is SketchuCam, a free add-in from Flatboys. And don't forget, this is a recorded session, so all that detail I'm handing out in a hurry can be found. So the first button, you set your work. Oh, I should set up maybe some units in my file. Window, model, and then maybe units. So I think I'll go to higher precision. I'm in inches mostly, but in my newer stuff, I'm doing metric. Yeah, so inside this first button, I get to set up parameters like how many RPM I want the cutter to go. And we'll put a feed rate of, say, 30 inches a minute and 10 inches plunge. The material thickness. So would you like, I'll cut it out of this nice piece of, little piece of birch that I have here. So it's 1/8. So let's put 1/8 on that, 1/8. Let's go a little more than 1/8. How about 9/64? Okay, let's sort of make sure that I get through the material. And I'm going to use a 1/16 cutter and no tabs. Doug does tabs, but I tend to not. Now, the safe width for this machine, this is a 3018. So my X is 30 and my Y is 18.
Now,
Whoa.
Darcy, your comment about no tabs. Have you not had any problems with stuff breaking loose?
Depends on what you're doing. I cut a lot of thin sheet, and I cut the parts in one sweep. So tabs aren't as important for that. The thicker the piece you're cutting, and the more you're doing passes and stuff, that increases the chance that you need it. The shapes of the corners matter, like round corners.
Oh, okay.
That makes a big difference. Yeah.
Yeah, and Ray's been advocating the use of tape for work holding.
Yeah.
And when you use tape, it's holding everything down. So you might not need tabs in that case. But so it's all like it's your own technique that you'll eventually develop.
Sorry, I'm just kind of curious. The point about tape. Do you mean double-sided tape where it's held down on the work surface?
Yeah.
Oh, okay. Okay.
Yeah. There. So this is an overhead gantry machine. I'll put it on multi-pass, even though it could probably do this in one shot. But just for the fun value, I'll just make it do more than one pass, just so they can see that you can do that. Normally, if I'm cutting like 1/8 birch ply, I would just cut it in one sweep, even 1/4 inch, or I would just whip through it. I wouldn't bother doing layers, But to make it more exciting, maybe I'll go to 132. So it's theoretically going to do 4 or 5 passes because I've got 9/64 there, and that's it. Now that is the definition of our job, which includes like the size of the material and the cutter I got. And all I got to do now is use these next 2 buttons to indicate where I want to cut. This is the inside cutter. I'll put the inside cut there. Inside cut, inside cut. Pick the outside cutter, and boom. Now we're ready to go. If I zoom out, you can see that on my machine, this is the 3018 work area. It's put this guide on there. Automatically, when I was putting the parameters in, it threw that down for me.
Okay.
So that is the definition of the work. Now we're gonna run it automatically knows to cut the inner holes before it cuts the outside. Because if it cuts the outside, the piece becomes loose, and then you can't cut the inside because now it starts floating, and it'll hop onto your cutter and start spinning around at 10,000 RPM, and then it'll come flying at you. So that's it for that. Now I'm going to use this green button here to make the job for the CNC machine. It's going to be called Untitled on my desktop. So I go over there. Done. So that's it for the CAD side. Now, or the CAD and the CAM. Now I have this program running right here. And I'll turn on, well, first I'll show you the program. Where is, oh, it's not running, it's here. This is the controller for the CNC machine. And what I'm going to be doing here is, first, I'm going to service, and I got to make sure the machine is hooked up. You see, it's on COM 3. So you plug your USB thing in, you wait to see what COM port shows up. Make sure your CNC controller goes to that. And then that's it for config. Next, file, open. I just go get that file that I generated. I'll switch to, what was it called? Untitled?
Untitled, yeah.
Where is it?
No, it's down, there.
There it is.
Left. Nope.
Oh, that thing.
Yeah.
Got it. There it is, see?
Okay. Okay.
So all I'm going to be doing from this software is jogging the machine right here. You see? Finding out where 0 is, and then setting up where 0 is, and then hitting the go get it button right here. Okay? That's all I'm doing. I'm going to 0 the machine and run the job. Okay, so I'm going to turn the share off so it's easier to focus on my CNC cam, which is right here. Oh, you guys can see my CNC cam. Hi.
Oh.
Hi, Adrian.
Hey, Adrian.
So you can pin the CNC cam if you want. So now, so these are the recipes. So here I have, this is called a spoil board right here.
Do you think you're sharing, or you?
Well, there's a camera, and there's an extra camera called Darcy CNC cam.
Oh, I see. Okay, thank you.
So that's where the goodies are happening right now.
Okay, I'll pin that.
Yeah, you can pin it. And so this is a spoil board here. It's just a little piece of scrap wood. I'm going to put that on the bed because after I cut through the piece, I don't want to cut into my bed. You can. I mean, it's your machine. You can cut it down. Oh, most of my CNCs have tons of cuts on the bed. I have gear shapes, and it looks like, you know.
Darcy, within the traditional woodworking group, the big sin, and I must admit I've committed the sin, is on your drill press to not use to go through your sacrificial wood and go right through to the drill press table and forever have a little hole in your drill press table.
Yeah, it's even better if the hole in the table isn't lined up as well.
Yeah,
I mean,
that works.
Yeah, that's where it's true.
So you'll be introduced to that concept when you get a CNC. But anyway, so you've got your spoil board to make sure I don't cut up my bed. And then here is my workpiece, which is just a piece of 8 birch. So I'll slap that layer down. Now these are just, this is like little bolts that are upside down in the channel. I know my big fat hand's in the way. But what I'm up to here is I'm just, I'm actually gonna rotate this, is I'm just using this little as a clamp, and I'm just spinning down the wing nuts here to hold this down.
Your table looks like it's bent.
It's probably the angle of the camera or something. I don't see anything bent. In what way?
The second bar from the left on the right hand edge seems to be pushed down.
Yeah, I think that's the pressure from the clamp.
Yeah.
But the clamp was loose when I first noticed it.
Oh, okay. Well, maybe he's been clamping there a
Is
lot. Yeah, right there.
I don't know what you mean.
Well, right at the edge. Well, we can see the edge of the machine, so that's.
Oh, it's perspective.
But
I don't know what you mean.
the other two look flat though.
To what?
Table slots.
You got a straight edge or something to put along there, Darce?
Yeah. Eliminate our confusion.
A straight edge?
Yeah.
Darcy, don't you love all these assistants?
Yeah, I don't know what they're talking about though. What, you mean this?
Well, it looks pretty good.
Yeah, there is a very minor depression there.
There
I
is
think it's
on a
geometry
couple
of
of them
my
actually.
camera.
Yeah.
Like I'm trying to rock this thing and nothing's happening.
No, you definitely have a depression along that second slot. It's pretty minor. It looks exaggerated to us,
My
but when you
glasses.
put the straight edge down, you can see a depression there.
It's true.
My glasses.
It's true.
I don't know what you mean. Let me. Really? I don't know what you mean. I don't see nothing.
Oh, put the straight edge back there.
Put the straight edge on it and then look at the face of the straight edge against there, and you'll see there's a gap under the straight edge
There's
along
a small depression there.
a little bit.
Maybe you see it on the video. I can't see nothing.
I actually see a warp in the table. But anyway,
Okay.
just to drive you crazy, I'm seeing it.
You guys just give me a hard time. That's what. That's
Oh, you
This is
brought
the
the
last
squirrel,
demo you're
dude.
gonna do.
You brought the squirrel. You got this coming, man.
You guys are ribbon. Okay, so let me slap this down. So I'm going to clamp it, and you'll develop your own kind of strategy for however you get around to this business of work holding. I just clamp that puppy down there. Then I'll clamp this other one. This is probably very not optimal. Normally I would get more scrap wood, and I'm looking down there to see if I can find more. And I would prop up the end of this, you get it? So it'll be a level clamp.
Yeah.
But I'm just being lazy, trying to make it look like it's really simple and trivial when you're using this machine. And I'm getting like a funny result here because that.
In all fairness, Darcy, having had many years' experience with a full-size milling machine and doing metal, the setup, it takes oftentimes more time than it does to actually do the job.
See, if you were using a laser cutter, I'd be done already.
Yeah, exactly. Yeah. So I got laser, and definitely that is a good technology for this type of work.
Man, there's a lot of hecklers.
Table leveling is really important.
Well, see, I don't mind heckling because I am quite confident I would have gotten the same in reverse.
Oh yeah.
There.
Good.
Okay, that's not perfect. I can see it. I can even move it very bit there. But generally, you want things flat, all the normal stuff. But this is just a demo to cut out my square. So now I'm back to the software I showed a second ago, and I'm going to simply jog the machine. Now, these types of machines are easy to jog. If I wanted to, I could stick my chubby arm there, and I could just rotate this thing, to jog it. Or you can simply get in here and just, press the jog button that's in the software. And then to not waste too much material, I'm going to cut it from the left corner. Maybe somewhere towards the left corner, right about there. And then maybe bringing it down. So just bring that up just a hair, so that now if I move it any closer to me, yeah, that's a good starting spot, I think. Now, in the software, the increments are pretty big, and I can set that, but, why not just stick my hand in here? Because the power's on, and everything, you might as well. And, it's not as bad as it looks. And then now on the software, I'm just setting up zeros there. I'm telling the software that's my start point. And it's an arbitrated thing, like in the cam side, I'm deciding where 0 is. And when you do it in SketchUp, the default is put 0 at the lower left. There's a way of getting another 0 somewhere else, but this is good enough for me. And if I haven't made a mistake when I did the cam, this is ready to go. So I'm going to hit the go button now, and it's going to start throwing chips all over the basement.
Do you want to start your spindle, or is it connected?
It's automatic.
Oh,
Thank you
okay.
for reminding me.
Yeah.
Doug there is...
I'm on the manual side. If I don't start my
yeah,
spindle...
no, I have a couple machines like that too. And you have to start the spindle, then start the machine. And if you do it in the other order, it's okay, but it's going to break your cutter.
Exactly.
Because these things have to be turning, okay?
Yeah.
Yes.
Otherwise,
You do it
no
the other
cutting
way.
for you. And you'll be out $5, depending on what kind of a cutter you have.
Yeah.
So I'm going to hit the go button now, if I can find it in the software. Always look to make sure you think your 0 is where it is. Because, for example, if the machine thinks 0 is 4 feet below the table right now, when I hit go, we're in for a surprise. But anyway, send. So it's just doing all that stuff that I did in the software a few seconds ago.
You're gonna hold it down with your finger?
Yeah, if you're gonna hold things down, you're supposed to hold with a piece of wood like this. You know? Don't stick your finger in there.
Yeah.
Because
No sense of
it's
adventure.
got square corners.
Not too loud.
No, it's very good.
See, and just now that they do generate dust and stuff, but just so you know, all the dust is on the piece of wood. I just see a couple of snowflakes underneath it right here. Like the radius of where the dirt's going is about that big.
Wait till you
Because
increase
it's
your
a
wattage.
1/16 cutter. So if you don't tell the wife, she won't know.
See ya. Take care, Pat.
Oh, she'll know.
So what I did is I cut too low there, and I wasn't paying attention. I was daydreaming, and then the piece popped out. See, because I cut below the surface to make through, to make sure. What I normally do, as soon as it's through, I pause the machine, and then just pull the piece out. So there it is, piece. On my other camera.
Your other camera. Yeah.
Yeah, I hit it with the cutter. That was a non-pro job. Now, I just did that for the fun value as steps, but in practice, I would cut this just in one run, and I wouldn't need to worry about, you know, the job finishing and then the machine still running. And to show you how easy it would be to refactor the job to do that, I'll just throw my screen back on, and I'll very quickly refactor this job. So I'll come back to here, come back to the software, and then come back into this button and say, please don't do multipass, do it all in one shot. Just like that. Then say, okay. Then regenerate the job. We'll call it Untitled 2 because that's extremely descriptive, and that's later I'll know exactly what that file is for. Deleting. And we'll be picking
exactly.
Open. And I guess I have to do all files because it gives me a funny extension. And now I'm looking for Untitled 2. There, that's a single, that job does it all in one crack now. So in the software, I'm going to raise the cutter a little. And then maybe I'm going to scoot it over to the right a little. I'm going to reestablish my XY coordinates as 0. I'm not going to touch the Z coordinate. I'm going to save that because I've already found the top of the surface where I know I'm going to start cutting. So we'll turn the share off so that in theory you can pin the CNC cam, and then I hit the go button again. And this time we're going to be cutting 1/8. I haven't used this machine very much actually for 1/8. I've been using this for plastic, so I never really tried it on this, but let's just run it and see what happens. Oh yeah,
A little louder this time.
yeah, it's stressing a little. I should have used a slower feed rate. See, I could have used a slower feed rate. That was really pushing there. It was moving, the cutter was bending all over the place. But in any case, now that it's done, I'll take my other cutter and stick it in here, and there's the part. Drop it. Don't blow on it to get the stuff off. Drop it. And the stuff comes off from dropping it. If you blow it, you're just throwing your dust into the air. And there. So that one came out perfect. So I'll just, I don't know if you can see that on there. Yeah, no sanding or anything. I just have to rub any burrs off of it if there's any pieces. So that there. So when you build with this, pieces are going to fit together as you saw with the dump truck. So there.
Cool.
Boom.
My reaction as I've been doing this stuff is that it makes you the world's laziest woodworker because it's so easy.
Well, you know, but you know, you can still do woodworking. You're not taking it away. This is an ad.
Yeah.
Hey, Greg, you have to say I'm the most productive
Adding it
woodworker.
You have to know the characteristics of the wood still. Even with the gluing, you still have to do the sort of stuff that you were doing.
Yeah. Oh, yeah. No. It's just. I'll tell you. There's one piece on that thing, the little roof of the digger. And there's an array of 8x5 holes in the roof. And of course, so there's 40 holes that have to drill. So I thought, well, I'm not going to bug Doug. I'm going to just do this on my vertical milling machine. Well, as I'm doing this, going through this tedious thing, thinking, my God, this is really boring. It'd be so much easier to do this on CNC.
But I mean, you always get the, you know, like I've been posting some of my printmaking work around online.
Yeah.
And I don't keep it a secret that I use a CNC machine. I think it's a great tool. And, you know, and I get the occasional person who will try to, you know, put me down a little because I'm using a CNC machine.
Yeah.
And you get this all the, that's a normal thing. I mean, like I get the same thing with my electric bicycle. Like I'll be pulled up beside some lady, you know, and she'll say, "You're cheating." And I'll say, "Yeah, but you're wearing shoes." You know, everybody has a different purpose in what they're doing.
Yeah.
Anyway.
Hi, guys.
Hi, Adrian.
Oh, sorry. I don't know whether I'm on mute or not.
I can barely hear you, Adrian.
Yeah, your audio is down.
Barely hear me? Is that better? I don't know. Can you
Can't hear you.
Yeah, still have poor sound, Adrian. Your mic's hidden somewhere.
Yeah,
But
okay.
anyway, gentlemen, so my friend Bill Cull is online here with us today, and he's an old friend of mine. But we go way back. He was one of the earlier people to actually help publish my squirrel project, which is a rubber band airplane. Some of you guys probably don't even know about this, but I actually have a business that makes rubber band airplanes, like big time, and got popular like many years ago. And Bill was one of the early enthusiasts in that project. He made the model, he helped promote it, he posted it on the webpage. In those days, his webpage was like probably one of the most central web pages for rubber band airplanes in the world. This is a decade ago. Anyway, so he's got a show and tell for us. We've been talking about the Hack613 space program, so I think we finally recruited somebody who knows what he's doing.
Hey, I object.
I was just going to say, Dave is going to object big time on that.
But this is water rockets. So
This is water rockets.
Oh, I
Yeah,
have
this
something
is-
to contribute after he
Dave
talks.
has real rock. Okay, water rockets are real too. This is the same thing about the CNC. You guys are trying to beat up on the CNC concept.
No,
and
no,
then
I'm quite
there's the
interested in
rockets
this.
too.
Trust me, I got something to show after him. That's not my work, it's someone else's, but yeah.
Oops.
Feel free to introduce yourself too, if you have anything else to add, Bill.
No, am I live now or?
Yes,
Yeah, you're there.
you're in it.
You're welcome to share your screen and so forth, whatever you like.
Okay. Well, first of all, I'm going to show my launcher, which is the Pittsco launcher. It's a tripod here. Now, I purchased that. Some people try to build their own launchers. You know, maybe this is something you could do with your CNC equipment, but it has to be pretty substantial to hold the bottle in. There's 2 O-rings on the launcher, and then this goes into the bottom. And this one's tight. Sometimes they're a little tighter than other times. Okay, so that goes into the bottle, and then it pulls down. And clamps.
Are those spring loaded, the little clamps, or not?
No,
No, okay.
so you have to get that where those grooves are, and then this part here, this collar, goes on the bottom and holds those apart, and you have to have it like that.
Got it.
You pump it up with a tire pump. I have tried like a electric motor, and that works, you know, but it seemed like with a motorcycle battery that it ran it down fairly quick if you did a bunch of it. It seems like just get a good quality bicycle pump, and that works well. I tried a cheaper one, and it started having issues after a while. So how I got started with this, I worked for the city of Winona, where I live, and they had a summer program called Model Airplanes and Rockets. And I did the model airplane part, and somebody else did rockets, and they did the Estes rockets.
Yep.
And I thought, well, I wonder if there's a cheaper way, of doing model rockets than, those Estes rockets, which are nice, but, the motors get kind of spendy when you're doing it with a bunch of kids. So I guess I just cruised the internet and found water rockets. And so I ordered the launcher from Pittsco. It was like a little over $100, but I had ordered a cheaper one, and that didn't seem to hold up for the pressure. It seemed like at about 40 pounds, it would start leaking. So, I mean, that's an issue. You need something pretty substantial, usually pumping these up to, close to 100 PSI. And the string, it's back probably about 10, 15 feet. You pull that, and the rocket comes off there. They claim it's about 100 miles an hour within about 3 feet. And it shoots out a big kind of cloud of water vapor. It's fun if you have a fairly fast camera and take a picture of that. You'll see this. So, I wanted something simple to do for the kids. First, I tried the 2-liter bottles, and then I went to like smaller bottles, like a 20 or 24 ounce bottle. And the top part of it is just a swimming noodle. And then you cover it with tape. You can see this one has duct tape, and just try to make kind of a dome on the top. And that seems to go up pretty good. It seems, it makes a difference if this is not real tight, just a little vibration or distortion as it goes up will make a difference in the altitude. For the fins, I'm just using fan fold foam. I mean, it's not rounded off. I'm sure you could do something that was a little more streamlined, but this is fine. And when it comes down, it just bounces, because you got the foam. If it hits you on the head, it might hurt a little bit, but it's I don't think it ever is going to hurt you. But that's what I do for the kids. I had found another system, and I don't seem to find it now, but it's called the Quest launcher. And they came with like pre-cut fins that you put on the rocket, and then it had a nozzle like this. So it was like you had to use this nozzle with their launcher, but then their launcher was only like $40, I think. And it didn't go up quite as high as the other one where the full force is coming out of the rocket, but it did go up pretty good. And I used that once for a college for kids class in the summer because we didn't have a whole lot of room, but it still worked pretty good. Now, I've tried, different things to get a parachute to come out. It's harder to do than you would think. One way was just you make, kind of like a cup on top and put the parachute in there and hope the cup stays on top and falls off as it gets to the, apex of the launch. And that works about half the time. The other half, it just comes down. And then I'm going to get something. I tried using, you've maybe heard of, they usually call them Tommy timers, these little wind-up units.
Oh, okay.
I know you can order them from some free flight places, vendors, because they use them in DT timers. So first I used this and I had a plunger on it and I was trying to push the top off, and I think what would happen was it pushed it off okay, but then the force of it going up, it just pushed it back down and it never came out. So then I tried opening up a side hatch and get more of the wreckage. And that worked on another rocket pretty well, but then this latest one, you can see it crashed. And the thing is, you know, you run into that with the model airplanes, like sometimes you don't know what caused the problem because it's so smashed up afterwards that it's hard to tell. But it's a lot of fun trying to get the parachute to come out. And I think some people use some kind of a speed flap with rubber bands. And I know Pittsco, they had a system where there was like a bellows, and it was like it was sucked down in, and then the air pressure, it slowly expanded this thing, and that worked some of the time too, but not all the time. I guess I can share my screen. I'll bring up my web page.
Yeah.
Looks like something that could be made.
Yeah,
Yeah.
I think so.
Okay, let's see. I got my website. It's Ideas Inspire. It was Science Guy, and kind of got in a disagreement with the IS, the vendor and whatever, and changed my domain. So let's see. I'll share my screen. And this one. See, is that sharing now?
Yes.
Yep.
Okay. So here you can see the launcher, and the tire pump, and you could see the kids really had a good time with this. This was one of the park rec kids below that, and they sent me a card thanking me. You can see the building sessions going on here. I had, you know, like about 3 people helping me, and you know, we went through a lot of kids in not that long a time. Use a low temperature hot glue gun.
Yeah.
Here's another, the one hobby shop. They used to have a Saturday morning program where they built things. We did the water rockets, and it was really popular. Here's some of my materials, the fan fold, and here's the noodles.
Oh, okay.
And as far as cutting out the fins, and it wasn't CNC. You could see the crude little hot wire jig cutter I made, or you can use one of these where they sell for model train.
That'd make Darcy really proud to see that, because he loves those hot wire cutters, just especially in MDF like that.
Okay, I had made a jig kind of to just locate where the fins go on. And here's a kind of a diagram of the rocket. And there's a certain length that's probably, going to be optimum. There's, a balanced part in a rocket, just like an airplane too, to keep it stable, but it doesn't seem to be too critical. And here's some of my early attempt. You might remember these. When you were a kid, they had those little pump-up rockets. I remember having one, and you can still buy those.
Yeah, they're a lot of fun.
I had it too.
Yeah. That's cool.
You can see the spray coming out.
Yeah.
So, then there was this other company, Anti-Gravity Research, and they did a rocket where they had the fins were rubber banded on the bottom, and then there was just a foam donut on the top, and they just had a tube that went through a small hole, and it seemed like at a certain point it would just release. You didn't have any clamping, and the rocket went up, of course, slower. Now, I found this program called Tracker online, and it, like analyzes the video frames. You take a video and then it graphs it, and I was able to, figure out, how fast the rocket was at a few feet off the launch and that sort of thing. So that seemed kind of like something that would be fun too to make this educational. I also bought one of those altitude devices. You could probably make your own, where you try to sight the angle and then use a little bit of trigonometry to figure out how high it goes. And here's where I got it to work, just having the top of it fall off. And it's pretty neat to, of course, to see a parachute. And here's where one of my first trials of using the wind-up timer and pushing the nose off. And it worked a few times, and then it didn't. And here's another one where I made a plunger to push it off, and that didn't work all that well. And here's two of the side deploys. The one on the left actually worked quite a few times, and then I don't know, it just got so beat up I quit using it and tried to build a new one. Here's that Quest launcher that I was talking about that uses the special nozzle on the rocket. And there was the summer class where the kids built these.
Nice.
So that's about all I have to present on this. I don't know if there's
much
any
appreciated.
Yes.
That's very inspiring.
Yes.
Oh, I got a few things I want to share related to this.
Okay, Dave.
So first of all, thanks, Bill. This is really cool stuff. I'm a rocketry guy. I do high power rocketry in general. I haven't done much with water rockets, but I have seen a little bit that I think would be useful for you. So when I was in Australia the last time, when I thought I was moving there were a family out with their water rockets. Now they're very sophisticated. They currently hold the unofficial world record for altitude. But what they were flying there that day were multi-stage water rockets, about the same level of sophistication as what you're flying, a little bit more, but basically the same. They do have an instructable, so I'm gonna share my screen here. Where are we? Okay, so this is an instructable for how to make it. You can see the two-stage water rockets there. And they do these, I mean, they have a lot of variants on this. They've been doing this for years. It's 3 generations within the family that are doing this. So like the grandfather, the parents, and the kids and all that. So they've done a lot of work on this, and they can get pretty sophisticated. So this is a staging mechanism that doesn't use timers or anything like that. It's all pretty, so this is the materials that they're using to construct it. It's all off the shelf stuff. right? And they have some pretty good directions on how to create it. Now, I've not done this myself, but I have seen these fly, and they are impressive. Now, these people have also done some recovery setups. And typically what they're doing there is, again, they fly with a lot of the high power rocketry guys, and they use something that's...
sorry, I got to get your picture in here. Sorry, just give me a second.
Yeah. So this is a timer that I've used for staging on my high power rockets. Okay. And it has barometric and accelerometer sensors in there. And what it does is it detects liftoff, and then there's a timer in there that's settable, and you can use it. Typically, I've used it to fire pyrotechnics to launch or to ignite a motor, or you can also use it to fire a parachute or whatever. But what these guys have done on their water rockets is they use a servo release, and, and the parachute comes out.
Cool.
Now, if you want to get really, really stupid, as in spend a lot of money and get really sophisticated, they make their own rocket. And I'm actually just going to launch the video here. I'm not going to show the whole thing because it is a bit of a watch. Oh no, it's only 135. I thought it was more than that. Okay. So in this one, they've made their own pressure vessel. And their pressure vessel is made out of carbon fiber and fiberglass and all that kind of stuff. So a little more than you really want to do yourself. There we go.
Oh my.
So this thing, that's a water rocket. They have this thing pressurized to about 1600 PSI.
Hi, I'm George, and boy, did we have a good weekend launching the Horizon rocket. Oh yeah, and welcome to part 18 of the Horizon series.
So they have a whole build series on how
the
they
fixes we did to the rocket seem to have worked, and the rocket behaved itself. We did two...
Okay. I'll post the link for this, but I'm not going to make you watch the whole video. But they do have a whole build series, and in that build series, obviously, they talk a lot about this really high power one. But they also talk about just the smaller ones, the multi-staging, all the techniques. One of the things that they mentioned, so in that rocket, for example, they actually only have 2 liters of water, even though it's a 7-liter pressure vessel and the rest is just compressed air. Mm-hmm. But to that 2 liters of water, they add 20 milliliters of a sudsing solution, and they use shampoo. And apparently that gets them 20 to 30% more thrust. Significant amount of thrust. So that's something you could do easily with your water rockets.
Yep.
Just a very small amount of shampoo to make it suds, and apparently that gives you a big boost in power. So anyway, that's what I wanted to share. I did see these guys fly in Sydney, so I mean that's what made me look up the multi-stage stuff, and then that followed me through onto this stuff. But yeah, you can do a lot with water rockets. It's not a you know, it can be as inexpensive for students like you want, or it can be just a very, you know, push the limits of engineering and rocketry kind of deal. So yeah, I'll just copy the links here and forward them to you in case you want to check them out.
Cool. I want to see it land, like the you know, we come back and land on it, like butt end land, you know, the little twisty plate.
Right.
I want to send
well, they do parachute recovery, so it's not entirely.
Yeah, no, it's very cool. Thank you for that.
But they've also did a bit of a test because they had one that just. So again, it's a carbon fiber tube. But the combination of being out in the Australian sun and the heating from the pressurization of the vessel heated the epoxy so that it softened on one side and the whole tube kind of tilted. So they wound up taking that one apart, and they have an aluminum nozzle that they use for that one. And I mean, they were able to clearly demonstrate that it would easily survive an impact. Now, another thing that's useful on their page, which I'm just posting the link for now, is they do have some simulators that can give you estimated altitude and things like that for your rockets. So you can feed in the parameters and see what you might expect in terms of performance. So again, from an educational point of view, you can possibly use that for some of your students as well. But
Very cool.
yeah, just knowing you were coming caused me to waste about 3 hours on Friday night.
That's what we're
Pretty
about.
fascinating stuff. These guys are pretty sophisticated in their approach. It's not something you're going to do with high school students, but it is absolutely fascinating.
Yes.
I know at the local high school here, I got invited one time where they had to try to launch an egg, you know, and get it to come down without breaking, and they all broke.
Yeah, that's actually, you know, the big thing about not breaking the eggs is it's a pretty standard setup, so that as a competition, it's not that much of a thing. When they do it competitively at the national meets and so on, it's actually an altitude contest for the egg. So you have to recover intact, plus whoever gets the best altitude.
Okay.
Yeah. Interesting.
So anyway, the links are in the chat there if you want to check them out.
I grabbed them. Thank you.
Yeah, just seeing how they make those pressure vessels is pretty interesting.
I saw someone was using a PVC pipe and doing something similar to this, and it was a 2-stage black PVC rocket rather than a balanced carbon fiber, and they had wrapped it with some plastic. So there was a level of compliance to the tube, which added to sort of the whole thing would shrink slightly once you release the pressure. But yeah, it was going in the thousands of feet.
One of which is PVC is pretty heavy.
Yeah.
And the other is if you're heating to the point where epoxy is melting, you're going to have some effect on the PVC.
Yeah, you're going to have a soggy noodle. So, yeah, not so good.
But I mean, they do use portions of PVC on there. So, for example, the recovery section that holds the parachute, that's all PVC and stuff like that. So they are a pretty good mix of, you know, high tech when you need it and just, you know, plastic soda bottles when you don't.
Yeah. Nice.
So another thing that I've tried that some schools do, or, well, I think this is a brand name, but they call them stomp rockets, you know, just using air pressure and make a rocket just out of wrapping paper and that sort of thing. A lot of them, you know, they'd use like a 2-liter bottle for the bladder to, you know, and jump on that. And of course, it'd get all bent up. And I was asking a science teacher friend, and he came up with the idea of using a boat fender. And that worked really good, you know. You could jump on that all you want. The thing that I found when I tried to use it with kids, it's like, yeah, when I jump on it, you know, it goes fairly high, but you know, if it's somebody that weighs 70 pounds, not so high.
Well, this is where the 2x4 and leverage come in, and you're gonna
kind of like ringing the bell at the state fair.
Yeah. Oh, that's good.
Yeah, again, looking at the multi-stage, I think there's some things you could probably use in there, including how they make their nozzles and things like that are potentially.
I am familiar with that website, or the, you know, and their videos. I have watched those in the past, and really impressive what they've done.
Yeah, I can't see too many 6- and 7-year-olds trying that though.
No, there's too much economics in it, and there's a fun factor in just having a pop model going up. It's pretty cool, especially when you see, you know, a group of kids making a whole table's worth or a park's worth, and you can just go kind of crazy. I have great plans. Darcy has a little community center with a pool. Well, not pool, but like a wading pool. So source of water is readily available. Source of children is readily available. All you need is a pump.
Yeah, I was just thinking about that. It's almost worth buying 2 liters of pop, but I don't have a pump.
Yeah. Yeah.
What do you pressurize the bottles to?
Now, I was, you know, doing about 100 pounds, sometimes 110. I think they kind of warn you, oh, don't go over like 80, you know, but
yeah.
I haven't seen one blow up yet, but I understand it could happen.
Yeah, they did show in one of their videos that they gave out, but But I mean, they're pressurizing the scuba tanks to higher pressures, and he said this one's been through hundreds of cycles before it failed. So they're pretty resilient.
Yeah. Well, I remember making the fatal flaw of trying to fill, you know, those air mattresses, and I had a scuba tank, and I just sort of held the thing against it. I filled it way too fast, and it just tore the side out of like it was so fast. It was just, I can't explain how fast it was. And it wasn't like it was locked on. I was just
to pressurize theirs, and apparently their scuba tanks. They use 2 of them, so I don't know if you want 2, but it's 3,000 psi.
Yeah, that's
3,000 psi.
Yes.
Wow.
Yeah, a normal scuba tank I think is about 1,800 psi, but I guess if you're using more, they could have some other system to it. But yeah, that's a lot of pressure and dangerous for some of these things. Like the bottles, the rupture point is below that. It's one of the cool things.
When you're talking about the velocity off the pad too, their Horizon one, the big one, they did a calculation of 86 G.
Whoa!
Wow.
Yeah,
that's
a lot of Gs. So my rockets are typically, you know, about 20 or 30 Gs. Yeah.
What was the G-force on the rocket yesterday? It wasn't that high.
It's about 3G.
Yeah.
So space shuttle maximum was 6G.
Okay.
So, yeah.
25G would just set you back in your chair.
Well, beyond, I think the most a human can take, and this is like a fully trained fighter pilot with a G suit, is in the like 8 or 9 range.
Yeah. And then we black out.
And even then, very briefly. Yeah.
Okay.
And even then, I think they tend to not quite walk away. They're kind of bent for life.
Yeah. Yeah, I'm not sure how many G's the guy on the rocket sled did. He might have taken a few more.
Yeah, but he didn't have to be awake at the end of it. No.
Yeah, when they were doing the research, though, yeah, I mean, he blacked out in a few of those things.
Yeah.
It's amazing he survived his own tests.
Yeah. Those G ones are interesting because you watch the face and the face ripples because of the air flowing around it. And I'm going, that's super unnatural. That doesn't look healthy. Yeah.
I guess just a couple comments on this, you know, summer program. This College for Kids went on for 30 years. And when, you know, you really heard about STEM being a big deal, it was like, you know, there was like a waiting list and that. And then within about 2 or 3 years, it just kind of fizzled out. They, you know, have all different sorts of different programs for kids and whatever. But what I was doing, saw this, you know, kind of loss of interest. The last year, it was interesting. It was half girls, where, you know, in the past, it'd be, you know, almost always boys, just 1 or 2 girls. We did, you know, a lot of different little projects, usually something that would last, you know, just for the day. Did like model solar cars, mousetrap cars. 1 year I had them build a real simple electric motor. Then there was like a syringe hydraulic arm. That's on my website too. It's made out of cheap wood and popsicle sticks and that. And you use the, you know, syringes that, you know, for cows and that sort of thing.
Yep.
And it just seems kind of sad, you know, that this ended, and I'm hoping that within a few years, you know, they could get started up again. And, you know, it's just kind of sad.
Sorry, why did it peter out, Bill?
That's a good question. You know, there was like a, you know, a tuition that parents had to pay for this. And I think there was like, you know, if they could show low income, they could get a scholarship thing. But I think if, you know, could have found donation sources or whatever and made it free, I think, you know, it could have continued.
Yeah.
Well, sometimes programs like that peter out because the leadership just kind of fizzles out.
Yeah.
Not necessarily the interest.
Yeah. Well, this stuff is grabbing me because every time I look out the front yard, I've got a bunch of young kids who are 5 this year, but next year they'll be 6, and the next year they'll be 7, and they'll be right in the prime market. But there's about a dozen of them on the street, so.
Well, I'm seriously thinking I'm getting a bicycle pump.
Yeah, me too.
I got one.
Adrian's thinking of making a bigger one. He's going to use his whole lake as a water source.
My bicycle pump right there. It's got a gauge, you see, and everything on it.
Yeah.
I don't know if you can turn water rockets into clocks, but maybe.
Water clocks. There are water clocks. You know that. That was one of the original
use a water
ones.
clock as your countdown timer.
A flying one.
Yeah. Well, a flying. Now there's a challenge for Adrian.
Yeah, have a countdown timer that automates the launch.
You know, and the other thing is you know, the kids, they just really don't do much with their hands, you know, as far as building things. And for a lot of them, it was a real struggle, but, you know, some of them caught on pretty well, you know, with a little guidance, but it's pretty tough just with, you know, being one person and maybe a volunteer helping.
Yeah, a lot of kids do a lot of video these days. Like, you know, there's a certain age, if you're born after that time, you're probably just playing video right now. And then they keep doing that into an adult. I don't think it's sort of explicitly harmful. It's just that you can do other things too. And I think it just eats up a lot of time. It's like watching TV or something, you know?
Yeah.
A lot of skill losses, so.
Yeah. So I think a lot of this stuff's become like nostalgia, you know?
Yeah.
But there is changes. And we might think that nothing's happening, but maybe some of it is. For example, when I was a kid, an 049 was the biggest thing you could ever get in life, you know?
Yes.
Yeah.
If you're a kid and you're out on your bicycle with your friends and you hear off in the background, and then it's going around in a circle, you can hear the Doppler effect of it going around. You knew exactly what was happening and you were all headed over there. And now it's all electric, you see. So it's, you know, the phenomena is changed. So maybe some of what we're concerned about, some of it might be somewhere else. We just don't know where it is. Where, like, these kids are doing something somewhere, maybe.
Yeah. I think this is a great project for the big adults in the room, though. It's
when we finally get to do one of our park meetups, this might be a good.
Well, I've been a proponent of this for a while, and we just, it would be a blast, literally.
There's 24 kids within a stone.
See it now, some kid driving by and seeing all these like old men in a car flying.
On bicycles and hanging out in the park.
Yeah.
Shooting pop bottles into the air.
I love it.
But, like, you know, when I was a kid, like, there were always adults that are just like us that would come into the community and do stuff, you know?
Yeah.
And that's so here we are.
Yeah. Well, you can model behavior as a way of making changes, so I think that's a good thing.
Yeah. So I want to make a water rocket now. It looks like maybe a starting point. Like, we got CNC'd, we can cut up like even aluminum and everything. So we can make things. We just have to understand the requirements. Yeah. So they blow the water right out of the bottle, just bare, right? So you don't necessarily need a nozzle. Is that right, Bill? I know people make nozzles, but
yeah, the nozzle has a couple of functions. Obviously, there's the nozzle function, but there's also getting the seal while you pump the air in.
Yeah. But I mean, you just use a bare bottle. So like one option, if I'm right, you don't need. You could just the bottle's just open when it's flying. Is that
That is correct.
So you can have that. So the big problem now is how do you seal and latch on while you pump into it? That's the problem, right? Like, that's the big problem.
Oh, another thing.
That's easy. Pardon?
I think it looks like there's a one-way valve in the line on this too. So, you know, you pump, it'll go one way and not lose the pressure.
That's fascinating. But doesn't a bicycle pump already have a one-way? So in theory, couldn't you just pump in there and the system would stay up because the bicycle pump is a one-way, and then when it releases?
No, I don't think the bicycle pump has a one-way. I think the Schrader valve has the one-way.
Oh, it's in the bicycle.
It's in the, Yeah.
You say the one-way valve is in the
Oh,
pump?
if you look at
in
the
the tube.
directions for the two-stager, they do show you how to make a nozzle there with pretty standard.
There's no there's no check valve in there.
Yeah. But that doesn't mean it doesn't work. It just means you can't get to the same high pressure without it.
Wait,
but a ball bearing
I put my finger over this thing and pump it. It just see there's pressure after I stop pumping. See, I stopped pumping. I'm not pumping anymore. Oh, okay, try that again. I pump some air in there. And then,
all we see is you waving in the air at a squirrel.
Yeah.
yeah. Okay, you got to look at the right camera. But here, I'll turn. Okay, then I'll change it. No, it's keeping the pressure. So there's obviously something in this pump. Maybe it varies from pump to pump. I'm just looking for. There's so many clicks to turn your background off and on. It's crazy. There. Yeah. So if I'm like, so I got the pump here and I got this thing here. Yeah, there it is. See, I got my finger over it and I'm gonna pump now for a while. So I'm done pumping and I got this thing in my hand. See? Oh shoot! So much for my theory. But I mean, I'm leaking. Okay.
Yeah. But you saw that the valve went down when you took your finger off of it, which means that the pressure of the system is pressurizing your.
Incomplete seal.
Well, a minute ago, it felt like I was able to hold pressure in after I was done pumping.
Yeah.
I just don't have enough volume there, so the leaks go out too fast.
Yeah, there's going to be a limit to how much the pump will hold, though.
Yeah, but it's not an insurmountable thing. As I say, a one-way check valve could be nothing more than a glass ball or a plastic ball in a tube.
It's part of a bicycle. I'm sure it's not like the most expensive part of a bicycle, so it's probably pretty accessible, right?
Yeah.
And the bicycle's designed to go right on this.
Yeah.
So it's like made for it. Interesting. Okay, so I'll do an order the next day or two on parts so I can get something going.
Well, again, if you look at the instructables for that two-stager, that's all stuff you find around the house. There's not
the little gardenia ones are nice. They do the whole valve system automatically almost.
And he shows you how to make your own gardenia valve. So
yeah. So that's pretty cool. Wow.
Well, there's a slight pause here. Darcy, you obviously were following that Dragon rocket launch fairly closely. Unfortunately, I went to the news selling me, and of course, all the turmoil in the United States with the rioting, it totally swamped out the Dragon rocket launch. But as usual, there's a nice one right online. What I was curious about, Darcy, does that actually recover the boosters or not?
Yes, they did.
They did. They stuck the landing on a boat that was moving. It was really quite amazing.
Okay.
And it was raining and everything. It was pretty neat.
Okay, that's good.
Yeah,
because
the bird was a little further downrange than is typical for a satellite launch. I think they were like up around North Carolina almost.
Okay. Well,
it's interesting. So they really. So this was the sort of the full SpaceX concept of not only launching the astronauts but also recovering the booster rockets as well.
Yeah. So the only part that didn't get recovered is the second stage.
Oh, okay.
Yeah.
So, but that's true even for the satellite launches. They've started recovering the fairings, but the second stage is still unrecoverable.
Oh, okay. Okay.
It burns up on reentry. Is that what happens?
Yeah.
Or yeah. Interesting.
But I thought that was cool. I like their spacesuits look very 21st century. They make the NASA stuff look like.
I'm not a fan. I think they look like I don't know.
They look like motorcycle suits.
Okay.
The thing that kills me.
Science fiction.
Yeah, they look like a cheap science fiction. And the rubber boots are terrible. They look like gum boots.
Right. I forgot that.
Yeah. Anyway, personal taste.
Exactly. Yeah.
When did this group become a fashionistas? Come on.
This is space fashion. Come on. This is serious.
I hope this is being recorded for posterity because people aren't going to believe this, I tell you.
Yes, we'll be critiquing your outfit as soon as you leave the group.
Yeah.
So you got any show and tell yourself, Adrian?
No.
Oh, yes. There it is.
I promised you this last week. Look at that. What a beautiful, look.
That's a nice piece of woodwork.
That's a beautiful box for you. What do you think, huh? I don't even know if it's
can't
plugged
hear
in.
you.
Oh, hold on. I don't even know if it's plugged in. So how does one plug in a box, I guess?
Solar powered.
Yeah. I couldn't be bothered to do anything like that because that would require a little more thinking. All right. There we go. So it does nothing, as you can see, until
You can barely, we can barely hear the knocking back
okay.
of it, unfortunately.
All right. I have no idea where the microphone is in this, but I'll do it again for you. So here's the box. All right, I'll try it again. Right. So you can see the size of it. It's about 4.5 inches on the side, or 5 inches. So no, that didn't work.
Can't hear it.
You can just barely hear the clicking coming back. Yeah, that's not showing up for us, unfortunately.
I don't know what the hell's going on then. Anyway, so there's not much point in showing this unless you hear the damn thing. Anyway, the point is it detects a particular knock pattern. When it hears that knock pattern, it knocks back the time. That's all. All right. I just thought you might be amused by that.
Yes. It's fun. Yeah, I don't know why the volume doesn't go through there, but
okay, and I'm looking at this, and my input level seems high. Anyway, whatever.
Yeah,
must be a background filter. It's not voice frequency.
Revision 2 will have a microphone output that you can plug into his computer, so when you knock on it, his computer will be able to play it on Zoom. It'll be the Zoom box feature. That wouldn't be a problem, would it? Yeah. That's all good.
Anyway,
cool.
other than that, no, just plugging away.
Nice.
I showed my latest printmaking project. You might on my side cam, you can see. So I'll show you how my registration works. It's the most interesting part. So you saw this probably at another project where I've got a base plate where I would put the piece of paper right in here, you see? And so you stick the piece of paper in there for printing on it. And then you have this frame plate, which goes in front. And it snaps on. And I've got features on there. I don't know if you can see very well. But there's features, so it can't pull out, you see? So if you look at the actual frame, I don't know which camera you're looking at, but I'll try and get it in front of both cameras.
That one is good, yeah.
You see?
Okay.
So this guy, the square that sticks out, it's cut into the frame, and there's one on each axis so that you can't pull it out. Like there's nowhere, this thing snaps in there and it's not moving. And then these moon cutaways here are so after it's snapped in, you can just look at it and you can see if the paper is aligned or not in there. You know, if the paper slipped out. And then what you do is then you put your printing blocks in there, and then your final print is necessarily exactly placed on the paper. And no matter how many blocks you put on there, it's necessarily registered. And so this project, which I started yesterday, I got all these blocks that I made up. They're all different sizes here. You can see them on my side cam. And the idea is it's just like life. You got to fix 5x7, and you need to fit these things in life in the blocks in there. And then you have to print this, and you put all the pieces in different, whatever colors you feel like. And then you run it through my little printing press, which is an old die cutter, and then you do your next layer after that. And I want to explore layering the colors. And I already did 3 prints. They're not that interesting yet because I only did I just did a couple just to get the feel of it, and they're coming out kind of like this. I don't know which camera we're seeing here. There's one camera, and there's the other camera, like that.
Yeah.
So it's going to be a few more layers of colors like that, and it represents, you know, just you only have so much time, and you got to try to fit those blocks in there. You can overlap them, and you know, all that kind of business. Anyway, that's yesterday's project.
Cool. Oh, did you show your business cards?
Oh yeah, I made a business card as well,
which is interesting.
Yeah, so just for the fun value, and I was going to do a workshop if people wanted. I'll actually show how to design these. So I cut these cards. Is it my side camera or my front camera? It's easiest for you guys to see.
Well, I'm using the side camera.
Side camera.
The side camera, if you look at that, that's the business card.
Yep.
For inventor artists, and I found out that I can make some reasonably fine print, and it comes out really good. So then I made this card, which you can't see because the ink is inside the grooves.
Okay.
But this is actually a business card for my consulting business, and I actually printed a couple and a handful of them because when I have leftover ink from my other printing and leftover or paper that I had a bad print, I just turn it into business cards, and you get pretty good resolution. And I could probably make the print half this size and get away with it, no problem. So it's practically as good as a printer. And I'm cutting into cherry. This is cherry wood I'm cutting into.
Yeah, that's a really good print.
That is
like the text and stuff is very, very readable.
Yeah, if you look at this thing in person, it's just, you can look at it with a magnifying glass and it just looks like it's machine made. So I'm pretty impressed with what you can do with just the bits of this cheap cherry wood that I managed to find at KJP Lumber.
So I'm a little confused, Darcy. Did you actually engrave that? Like it's actually a dark layer with a light layer underneath it, then the CNC cuts through the dark layer? Well,
you know, I've got a face, and then I would engrave what is not going to be inked. It's relief carving. It's a relief print.
Oh, okay.
It wasn't dark until the ink hit it.
Yeah, that's right.
Yeah.
Oh,
so this
okay.
is a piece of cherry, which looks normally like this. You see, it's just cherry color. And then, yeah, so that the paper is white, and then I put black ink on that, and wherever I carve doesn't receive ink. And by doing it in the negative like that, it comes out kind of unusual looking, and I think at business socials, people will think I'm cool because I got a black business card. But the real
unlike those of us who know you, yeah.
Yeah.
Yeah, exactly.
Oh, he's cool. He's cool.
Exactly.
He's cool. He's cool.
They don't know me yet. That's the thing. But by doing it in the negative, I can put smaller features, because if you imagine you've got a piece of wood and you're cutting a small feature into the wood, there's no issues of strength of the wood. But when we want to make the opposite of that, where you have like a ridge sticking up from it, then you have more chance of breaking it. Anyway, I think it's.
How deep do you have to cut?
I'm using 50 thousandths of an inch, which is.
Well, that's not too deep.
Yeah, I don't even think I need that much. Like I think it probably somewhere of 25,000 is probably what you need, you know. And I'm just putting, and I could probably get smaller features if I were to go with that smaller number. And I'm using a 60-degree V carve, so you could use any V, you know, any old CNC could be doing that. And then and then to cut the outside out, profile cutting, I use the same cutter I just demonstrated earlier with my little 3018.
You don't
so that's the business cards.
It's a total aside. The fact that I can see my picture on your screen, Darcy, I realize how much of a delay there is in these systems.
Well, if it wasn't a delay, it would be real time. The universe would collapse.
Yeah, exactly.
I have to drop off for a little bit now, so that's been a real party. I have lots to think about.
Yes.
You guys have fun.
Talk to you tomorrow, Doug.
Righto. Take care.
Bye-bye.
Good day.
Bye-bye.
So another thing I've been up to is I finally bought model aviation flight simulator.
Oh yeah.
And so after using that, I got more interested in the helicopters. You know, I had tried to actually fly one, you know, a few years ago, and they're difficult, and I crashed them, and, you know, was always fixing and stuff. But wow, that simulator really helps.
Yeah, they're amazing. When I used to fly competitively, I got the G2 simulator, and this is like long ago, like 15 or maybe it could even be 20 years. I don't know. I got the simulator called G2.
Okay.
And it really qualified as real flying time. I used to practice for competitions with it. So yeah, it's a real phenomenon. Eh? Which one did you get?
The Real Flight 9.
Oh yeah, this is what I got. Mine was version 2, so yours is obviously better than mine.
Sir, can you expand a bit? I understand the concept of simulator, certainly, but what exactly is this for model airplanes or model helicopters or what?
Helicopters, airplanes, and drones.
Oh, okay. But are you actually have some kind of actual controllers that are all done through the keyboard or the mouse?
No, like I've got an actual controller that looks like the actual controller that I plug in through USB. And you can fly it from the ground, or at some flying sites, you can, you know, set it to view from within the aircraft. And there's a whole lot I haven't tried with it. I guess you can adjust the wind and this and that and stuff. But for the helicopter, I bought one now, and I'm doing a whole lot better than I did before. It gives you really a pretty good feel for how it reacts.
Well, years ago, I bought an electric helicopter. This is way before all the electronic gyros and stuff like that. And the thing was uncontrollable. That I don't understand. It amazes me that people actually flew these things at one time without that assistance. And I'm sure the guys that learned that are probably rather annoyed at how simple it is now.
I remember so many years ago, this guy in the Model Airplane Club, he built one, you know, all made these machining parts and that. And he practiced flying it in his garage, tethered down through the windows from the outside. And then finally he takes it out to our flying field and gets it in the air, and darn if he hits the only obstacle around was the transmitter impound.
Yeah. I remember years ago I bought a book by a guy that actually, it was a book describing designing these things. I mean, he went through, it was a very good book. He went through the math about, you know, the amount of the size of the rotor you needed for the amount of motion of what do you call it? Momentum you had to impart to the air to get the helicopter to take off. And there was he's actually had some. This is when I first got into machining, which is what prompted me to buy the book. And he actually had you know, he built little what do you call them? Centrifugal clutches. You know, those clutches that disengage when they go below a certain speed. Mm-hmm. And it was but I never actually ever built anything. I thought the amount of effort you have to put into this from a machining standpoint to achieve something you probably can't fly didn't make much sense to me.
You remember the name of the book or the author?
Oh my gosh, no! I think I gave it. No, I don't have it anymore. Yeah, I think I gave it away to somebody. We're talking about like 30 years ago now. But it was an interesting book to say.
They don't really expire. If someone puts the information together well, then it's kind of like a treasure.
Oh well, the obvious place to go is A-Books, Advanced Book Exchange for any old books.
Oh, there are a lot. Yeah.
Yeah, sort of. I think half of the books I buy there.
So the Real Flight 9 with controller is about 300 Canadian.
Oh, US it was like 179.
That's amazing.
Well, I think the 179, I did see a similar price. I'm seeing it on Steam for that price, but that does not include the controller.
Yeah, I remember when I got mine, it was like $200 or $300 or something like that. This is like, it feels like 20 years ago. It must be 20 years ago. You going, Ray?
No.
Oh, you waved to somebody else. Okay.
Adrian's going. It's something about time.
Yeah, I'm gonna leave too, guys.
I'm
Great chatting with you.
Good to see you again, Paul. Make sure you come on back.
Yep.
Yeah, see you soon then.
Great to see you.
Having seen the hoops that Paul jumped through to make the image recognition that cameras for work on a robot, I feel like a total cheat. I'm giving serious thought to buying a thing called Pixie 2. It's a thing from Carnegie Mellon University. It started as usual with a startup, and I've been looking at the software for that, and it looks like this kind of stuff is complicated no matter how you slice it. But it looks like the software that runs on Arduino is actually looks like it may be understandable. Let's put it that way. So of course the big issue is, can I get one of these things? So a Robot Shop says they're about $60 for these things, and Robot Shop says they have one in stock by the 2nd June. If you buy it from DigiKey, it costs $120, but they suppose they have it in stock. But I certainly don't want to spend that kind of money if it's just a matter of waiting a while.
Oh, I can wait.
Well, that's my reaction too. Yeah, exactly. Yes.
I've got so many projects on the go. I'll take the deal over although I want it yesterday.
Yeah, right. The trouble is, of course, mail is so screwed up now that, a matter of fact, I get The Economist it's a weekly magazine, and they've sent me, I usually download digitally and just read it on my iPad, but they've actually sent me email saying, we're really sorry, folks. It's going to be a significant, like 2 or 3 weeks delay of your magazine, and we encourage you to download digitally. So the post office, I think they're really struggling because they trying to do social distancing in a postal sorting plant is almost impossible, I think.
I'm glad that squirrel left. Man, those things are I know a lot about squirrels now, and they're really hard. They're impressive, but they're just...
It's funny you should say that. A friend of mine sent me a video of a guy obviously stuck at home, was totally bored, is making an obstacle course for squirrels.
Yeah.
And they're impressive little creatures, that's for sure, as far as jumping in is concerned.
They've got all kinds of things going for them. They actually have an ultrasonic squeak that we hear them in certain ranges, but they talk to each other and they're organized. And when one of them's up to something, there'll be another one that's a lookout. But it's up in the ultrasonic frequency when they shout the alarm, so we never hear it. It's like you need something that'll record bats to understand. So these guys, they're organized. Oh, I hate them. They're just killing my plants. Oh my gosh. And one was mocking me today. I swear to God.
You're getting paranoid.
Well, I'm not getting paranoid. He saw me looking at him, and he started doing this thing with his tail. I said, "You bugger! You know what? You get out of that garden." and he did this whole. That's peacocking, man. I know what that is. That's across the board. That he was strutting it, little bugger.
Have other people seen that video by, I think it's Mark Rober, where he sets up that obstacle course for the squirrel to get to the...
Yeah, that's what I was looking at. There's another video where it's not so squirrel friendly in the sense there's a squirrel trying to get them into a bird feeder as usual. And this thing launches the squirrel, like it just throws it right over the fence.
Yeah. I saw that. The squirrel launchers.
Yes.
There's a couple videos on squirrel launchers. I don't like squirrels, so.
fine with you.
Yeah. Well, they don't get hurt.
No. That matter of fact,
these things can paratroop in with. You can train these things for the military because they don't need parachutes. They
apparently just spread themselves out.
Yeah, they can fly. They can fall an infinite distance. Little buggers.
On that note, I think I'm gonna depart. You guys, it's been good, guys. We'll see you next week. Okay, bye, guys. Bye.
Have a good night.
Yep.
Yeah, I think I'm gonna cut out here now too. But thanks again for the water rocket stuff there, dude.
Oh. Yeah, that was
yes,
fun.
very much so.
Do it after,
thank you, everybody.
After the fake plague is over.
Yeah, I got to go buy a bicycle pump now.
I got one. I just have to use it now.